Since we've graphed a couple lines, let's look at graphing an absolute value of a line. See how that differs. So remember, absolute value of a number is the distance that number is from 0. So absolute value of x is equal to x if x is greater than or equal to 0, and the opposite of x if x is less than 0. The absolute value of 4 is 4 because 4 is already greater than or equal to 0. But the absolute value of minus 4 is the opposite of minus 4, also 4, and that's because minus 4 is less than 0. So if you want to think what happens to the absolute value of this line, you could just say the absolute value of a line like 2x minus 1 will be equal to 2x minus 1 if 2x minus 1 is greater than or equal to 0. And it will be equal to the opposite of 2x minus 1 if 2x minus 1 is less than 0. That's treating that 2x minus 1 just like you treated the 4 here. Now notice that the opposite of 2x minus 1 is negative 2x plus 1. So a line is straight all the way through the graph, but a basic absolute value graph, when you graph the absolute value of a line, what you get is like graphing two half lines. Think about 2x minus 1 greater than or equal to 0. If you solve that for x, add 1, divide by 2. Then you get x greater than or equal to 1/2. So this graph will be equal to that line if x is greater than or equal to 1/2. And when 2x minus 1 is less than 0, add 1, divide by 2. X is less than 1/2. So this absolute value of the line will be equal to minus 2x plus 1 if x is less than 1/2. Now we could graph this line. We recognize the slope. We recognize the y-intercept. This one has a slope and a y-intercept. But we have to mark scale properly. So if I have to observe the point 1/2, if the point 1/2 is important to me, I'm going to make steps about this size. 1, 2, 3, and 4. And likewise here. Try to make these equally spaced. I'd much prefer to graph on graph paper, but I don't have that on this board. I've seen boards that have little dots regularly spaced to help people graph though. Let's put a 2 and a 4 here. This is the x-axis. It's always helpful to label the axes. 2, 4, minus 2, minus 4, minus 2, minus 4. So you've marked the graphs with these hash marks, and then you've labeled each one. 1/2 would be halfway between 0 and 1. Notice what happens when x is 1/2. When x is 1/2, I get 2 times 1/2 is 1, and 1 minus 1 is 0. So that point is right here. And I could find other points for x greater than or equal to 1/2. I could just plug in some ordinary numbers bigger than 1/2 and see what happens to this line. If x is 1, that's not hard to insert. If x is 2, I can insert. So I insert x equals 1, and I get 2 times 1 minus 1, which is 1. If I insert 2, I get 4 minus 1, which is 3. And if I inserted 4, or 3, I get 6 minus 1, which is 5. That's a little bit off scale, but I can kind of project where that is. 5 is near the top of that arrow. Let's look what happens if x is less than 1/2. If x is less than 1/2, I'm to the left of that blue dot. So I could try a number like 0. Put 0 in here. It's easy to evaluate. I get value 1. If I put in minus 1, I get positive 2 plus 1 is 3. And if I put in minus 2, I get 4 plus 1 is 5. which is again relatively high up here. Now think of the absolute value of a line as two half lines. So I connect these dots nicely. And this direction also. As neatly as I can. It's not perfect. Let's darken this side up so they're kind of matching. And this is the graph of y equals the absolute value of 2x minus 1. It's kind of like a V, and it's symmetrically placed about this point right here, x equals 1/2, where the inside, where the line 2x minus 1 is equal to 0, and the absolute value of 0 is 0.